Let's evaluate these two integrals a and b using the given trigonometrical substitutions. In part A, we are given x is equal to 2 sine of u, and in B, x is equal to 5 tan of u. Hi there, and welcome to the channel. Now, in part A, x is equal to 2 sine of u. So we have x is equal to 2 sine of u. Now, let's differentiate both sides with respect to x, to u, sorry. So we get dx du is equal to 2 cosine of u. This obviously means that our dx is equal to 2 cosine of u du. So let's keep this relationship, because remember, we need to replace our dx with something in terms of u and our x squared into something expressed in terms of u. Now, x is equal to 2 sine of u. So what is x squared? Obviously, x squared is equal to 4 sine squared u. Let's also keep this relationship here. Now we've got this and we've got that, and we can now substitute into our integral. Now our integral is integral dx, all this over the square root of 4 minus x squared. Making the appropriate substitutions, we get integral of our dx is that. So it's 2 cosine of u du divided by the square root of 4 minus x squared is that, which is 4 sine squared u. Now we can factor out our 4 inside the square root sign to get integral of 2 cosine of u du, all this over our 4 out of our 2, sorry, because remember the square root of 4, when we take it out of the square root sign, is 2. So that becomes 2 square root of 1 minus sine squared u, like that. Let me just explain again what we did. We've got a 4 minus 4 sine squared u here. So when we factor out our 4, we can take it out of the square root sign, and when it goes out, it becomes a 2. That's the 2 you see here. So these 2 and the 2 below cancel out, and we are remaining with cos of u du over the square root of 1 minus sine squared u. But what is 1 minus sine squared u? 1 minus sine squared u is cos squared u. So we have got a cos squared u inside the square root sign, which obviously becomes just a cosine of u. So let's write it slowly. Let's not rush. So it becomes cosine of u du, all this over the square root of cos squared u, which is equal to cos of u du over cos of u. I'm sorry, my ink is rather splashing. That doesn't look like a cos squared u, but it's a cos squared u. Okay, so the cosine cancels out to give us just integral du, which of course is just u. But we are given that x is equal to 2 sine of u. So what is u? U is equal to arc sine x over 2. That is our integral. Now, in general, what this means is that if we are given an integral of the form integral dx of the form a squared minus x squared, where a is a constant, we must let x equal to a sine of u, or sine of theta if you like, so that our integral is u, which is equal to arcsine x over a. Okay, right. Let's go over into the integral b. B says we need to integrate 5 dx over 25 plus x squared. Now let x equal to 5 tan of u. We write it again here. X is equal to 5 tan of u. Now let's differentiate both sides with respect to x. We get dx over du is equal to 5 sec squared u. Now, if dx du is equal to 5 sec squared u, it also means that our dx is equal to 5 sec squared u du. So, let's keep this relationship. Now, we've got an x squared here. If x is equal to 5 tan of u, what is x squared? Well, x squared is equal to 25 tan squared u. Again, we need this relationship. Right. We go back to our integral now, which is 5 dx over 25 plus x squared. Substitution for dx and x, we get the integral of 5 times our dx is 5 sec squared u, 5 sec squared u, and down here we've got a 25 plus our x squared is 25 tan squared u. So we have here, simplify, on top we have a 5 times 5, which is 25 sec squared u du. Sorry, we forgot to put a du here, I'm sorry. So down here we factor out our 25 to get 1 plus tan squared u. Right, 25 cancels out with 25 on top and at the bottom. And here our 1 plus tan squared u is actually sec squared u. So we are left here with integral of sec squared u du divided by sec squared u. Because remember, 1 plus tan squared u is equal to sec squared u. So the sec squared u cancels out and we are left with the integral of the u, which is equal to u. But x is equal to 5 tan of u, which means that u is equal to arctan x over 5. That is our integral. In general, if we are given an integral of the form a dx over a squared plus x squared, we let x equal to a tan of u, so that our integral becomes u, which is equal to arctan x over a. If you are not a subscriber to the channel, please do subscribe, press the like button. That keeps us alive. Till we see you in our next video.